morning, everyone. This is Michelle Hughes from Ageless and Timeless. Today, I have a very special guest. Well, I always have special guests, but today, a very, very special guest, Dr. Bill Lawrence. He is, as you know, we've been doing a series on peptide bioregulators because we think at Ageless and Timeless that this is one of the greatest developments and breakthroughs in anti-aging. And we always say health span and lifespan because both of them are very important. So Dr. Bill Lawrence has a very interesting story. I'm going to quickly tell it to you, and then I'm going to let him take over because he's going to be showing us some very scientific background to the peptide bioregulators and the protocol that is being used has been used in Russia for 40 years. So Dr. Bill Lawrence was introduced to me by Phil Mickens, who was a prior guest on Ageless and Timeless, if you've been watching. And they've been friends for many years. And Dr. Bill Lawrence is the U.S. representative for the St. Petersburg Institute, which is headed up by a very famous scientist named Dr. Khavinson. And they are the ones that were approached by the Russian government to begin to find solutions for the deterioration of some of the people in Russia, particularly after Chernobyl, and some of the athletes and the military. And really, in Russia, you can buy these biopeptides, right? Like they're just food supplements because they are amino acids. And so you can buy them in stores, and they have been available that way for all these years. They're just starting to make an entry into, well, the last 7 years, I guess, they've been making an entry into the U.S. So anyway, back to Dr. Bill. He started out as an attorney, and then he moved over to real estate development. He was a tax attorney first and then a real estate developer. And then he recognized that lifespan and health span were far more important to him than making another 5 million or whatever in his real estate project. So he went back to school. This is just such an amazing story, but he went back to school, got his Ph.D. in basically in nutrition, I believe, and at University of California, correct, Bill? At UCLA?
Yes.
Yeah,
correct.
Okay. So he got his doctorate and he began to do this studying, and he's had a couple of these studies that he's done with people like you and me, or mostly now medical people, to test how the peptide bioregulators are affecting a health span and lifespan. And wow, he's going to tell you some stuff that's going to just knock your socks off when you hear about his the results. And so, Bill, I'm going to turn this over to you. And welcome to Ageless and Timeless this morning. We're so happy to have you on our show.
Thank you, Michelle. It's my pleasure to be here. Actually, it's my pleasure to be any place. I'm just happy I woke up this morning.
Well, we love to hear that.
Yeah, quick backstory, and then we're going to get into the presentation. I don't have longevity in my family. I was raised in the Mormon church where we do a lot of genealogy, and so I knew the history over a couple of hundred years, or at least a good part of the history. And all the men in my family line died in their 50s and 60s. My father had his first myocardial infarction at 57, fatal at 64. There was only one man going back about 200 years, not that we didn't have data on everybody, but where we had the data, there's only one man out of all of that made it past 65. He made it to 70. So yes, I was in my entrepreneurial period. I practiced law originally actually as a district attorney assistant in Los Angeles County, prosecuting cases where I learned the importance of data, or evidence as we call it there. Then practiced law for about 10 or so years, and then an entrepreneurial period. And what I found about myself was that once I learned how to do something, I get bored with it and it's time to move on. But my father's death triggered a whole new direction for me. I was in my early 40s, I guess, at that point. And I knew the history, but the fact that he died, at 64 was startling. And I decided that, yes, as you mentioned, Michelle, that earning a few more $1 million was not all that important if I wasn't going to be around to spend it. So I started researching, well, went back, got the PhD, started researching basically longevity and so forth. And I'll get into it in the slides in terms of how I got with the Russians. I'm running 2 clinical studies. I've been going now on the 7th year for the telomere study and about 4 years on the DNA methylation study. And what we're going to see is the evidence that these peptides, bioregulator peptides, which are very different than the regular peptides that are sold across the country. Not that those don't have some value. Most of them are synthetics. They tend to be used for things like weight control, cognitive enhancement, their growth hormones, libido, energy, and so forth. And those are valuable things. These peptide bioregulators are in a class by themselves, because what they do, if you see from this slide, is they can produce organ regeneration. They can reduce mortality significantly, and we're going to see the evidence of this, and they can actually reverse biological age. So let's go. We call it the Peptide Longevity Program. There's 2 clinical studies. There's a telomere study and a DNA methylation study. And as an attorney and as a scientist, this is so true. Produce the data. If you don't have the data, I'm not interested. I sit in medical meetings, Michelle, just like you do. And when a speaker gets up and starts talking about this wonderful intervention or wonderful product or whatever, and doesn't have the data, that's the time. Thank goodness those meetings have Wi-Fi. That's the time for me to start checking my email. I have no interest in studies that are not backed up by evidence, and they have to be human studies. Too few percentage or too small a percentage of animal studies actually transfer over to humans and so forth. So it's the data. In the legal business, we call it evidence. In the scientific, we call it data. So the precious thing that this slide is talking about Edison and Steve Jobs is time. That's that is more valuable than what you got in your bank account, is just time. How much time do I have in this existence? So these are the 2 studies, a telomere activation and a DNA. A client sent this little slide to me. Basically, that's me trying to pull back time and slow it down. And we all do that. That's what we're doing, we know, with the supplements and the various interventions and the fasting and so forth and so forth. We're trying to slow the time down. And that is a valuable intervention. I continue doing that as well. But there's another way of doing this. By the way, you probably have heard that billionaires are bankrolling huge investments in research, basically to slow the aging process down. And again, that's slowing the aging process. While that's valid, I think it's also helpful just to be able to add additional years. So it's a 2-prong approach. But they're spending billions of dollars at this point. These are people who have made their billions and so forth and have realized that they have a lot more money than they have time left, and they want to do something about it. So we have 3 parts of this program in this presentation. The first part is organ regeneration. Second part is mortality reduction. And the third part is biological age reversal. So there's 3 sections of this presentation. This is, of course, the aging paradigm that we're all familiar with, okay? We're young, and then we're middle-aged, and then we're older, and as we get older, we have all the vulnerabilities to various diseases and so forth. And Professor Khavinson and I at the St. Petersburg Institute have a very different paradigm. This is the picture of the paradigm that we operate under. So this is the institute that I'm affiliated with. I've been with them for, I guess, about 10 years now. I came to them because of Google Translator. 10, 15 years ago, even longer, I've been in this field 30 years now, I was looking for anything to do with longevity, interventions, et cetera, research, et cetera. Google Translator made it possible for me to be able to see non-English research, published research and so forth. So I could see papers from China, I could see papers from the Middle East, from Israel and so forth, and including Russia. And I ran across a paper that we'll come to in a moment, a published study that was the game changer for me. This is the Institute staff in St. Petersburg. If you've never visited St. Petersburg, it's a lovely place, so put it on your bucket list. These are brilliant researchers and scientists. Professor Khavinson is standing right in the middle of that. Professor Khavinson is extremely well known throughout Europe and virtually unknown here in the US, even though he was nominated for the Nobel Prize. He's been the president of the International Association of Gerontology for the entire Europe region, on and off for many, many years. He has published over 700 scientific publications, and yet he's unheard of basically here in America. It's a sad situation that America tends not to want to look beyond their shores in terms of science. Unfortunately, they'll look at British and Israeli kinds of studies, but beyond that, they're just not very interested. The original studies that were done, that I'm going to show you some of, were not just done in Russia. Some of them were done with the National Institute of Aging here in the United States, but also, as you see here, Germany, Italy, Spain, Belgium, and so forth, is where a lot of these studies were done. So they're not just Russian studies. It was just that the Russians were sort of the spearhead behind this.
Today's podcast is brought to you by Gematria Products. Gematria is based in Carlsbad, California, and they manufacture ultra high quality dietary supplements using QI technology. Qi, as you probably know, is the energy that runs throughout our bodies and is the basis of Chinese medicine. Use the code AGELESS and get 20% off your order. I highly recommend Gematria's products. I personally use the Complete Aminos, the Heart Gems, and the Methuselah Life, which is an RNA and DNA sublingual spray. The website to go to is www.gematria.com/QI-technology. And there you'll find out more about this fascinating company, their products, and the technology.
Professor Khavinson basically has said that what these peptides are is that they're signal molecules and that they regulate gene expression. And we're going to see that later in my presentation in terms of the gene expression interventions. This is the Hayflick limit. This is one of the two studies that caught my attention. The Hayflick limit, basically named after Leonard Hayflick, UC San Francisco, is basically how many times human cells can replicate. And the answer is they can replicate about somewhere between 40 and 60 times. That's the Hayflick limit. So what this study showed from Russia is that they could exceed that by about 20 to 30%. That caught my attention at that point, because in other words, instead of having 40 to 60, what we call passages, I could add another 10 to 20 passages, which would equate to another 10 to 15, 20 years. What Professor Khavinson's team also found was that with these peptides that become, they stimulate protein, what we call synthesis, and they're very specific. And I'll talk about where they come from and where they go and so forth. But what he found was that these peptides could create a biological reserve and increase that biological reserve by about 42%. For those of you who are as old as I am, if you remember, there were a few cars back in the 40s or 50s and some motorcycles. I had one in the 50s, where when you were running low on gas, you could throw a little toggle switch and there was a reserve tank in with the regular gas tank that would give you an extra, gallon or so of gas to be able to finally get to a gas station. Well, the human body, it turns out that Professor Khavinson's team discovered that you can create a biological reserve. And that biological reserve shown here will basically result in about 35 to 40 more years of life over the normal 75 to 80. The 75 to 80 is based on Russians and Ukrainian longevity reports. Here in the US, it's a little bit longer than that. But the idea is that we have within us just having to access that is, you have to have the trigger, and that's these peptides that will trigger that biological reserve. This is Professor Khavinson. He was in the military back in the 70s and so forth. And what was happening was that the Soviet Union military was aware that the US was developing lasers and audio kinds of weapons where they could blind the the other military on the battlefield, create hearing problems and so forth. They also were aware that the submarines corps that were going out back in the 70s and so forth in what today we would consider very crude submarines that were built in the 50s and 60s, and very crude radiation protection from the nuclear reactors, were coming back with all sorts of medical issues. So they'd be on a 3 or 4 month tour, and these are young men, typically in their 20s, the officers in their 30s, and they would come back and they would have primarily thymus issues, immune issues. And so the Soviet Union military basically said to their military scientists and officers, you need to figure out a way of protecting and basically regenerating through some form of rejuvenation these young soldiers. And so they threw a lot of money at it. And people have this idea that scientists just wake up with a light bulb lighting up over their head one day and they have a wonderful discovery. That, of course, is not the way that it works. You always build on the shoulders of people that have done the work before you. Probably the only exception that we know of in the world of science is perhaps Einstein. He didn't build on anyone else's research and discoveries. He thought it all up himself. But otherwise, so in this case, that's true. Ivan Pavlov, that most people know as the scientist that was involved in what we call conditional physiology, conditioning, where he was using the dogs to study the physiology of digestion, gastric juices, and so forth. And so when Professor Khavinson was given the assignment to figure out, to come up with something that would be protective and restoring the health of these soldiers, he used the work of Ivan Pavlov, who received the Nobel Prize in 1904, the first Russian Nobel Prize. He used the work, and it was Ivan Pavlov that had the concept of these very small, what he was originally calling proteins. Later, he named them peptides, and that's where actually the terminology came from. And the difference between a protein and a peptide is simply how many amino acids, and we'll get into this later. If you have a very small number of amino acids, then you have a peptide, and the arbitrary cutoff is if you have 50 or fewer amino acids in chain, and they can come from a lab or they can come from food, you have a peptide. If you have more than 50 amino acids in that chain, and some proteins have 1,000 amino acids in the chain, you actually have a protein. So Pavlov discovered, and then Khavinson used that work, and he figured out that if you have very, very short chains, that is 2 amino acids, 3 amino acids, 4 amino acids, those peptides are powerful because they pass intact through the digestive system, through the gastric system, and they can actually penetrate cell membranes, including the blood-brain barrier. So in other words, they can get into the cells and they actually get into the nucleus because they are so small, and that's why they're so powerful. So as I said, this is the submarine corps that they started using them in. Then they expanded it to the Soviet Union cosmonauts. When they would come back from space, they also were experiencing various medical issues, and again, primarily immune compromised. And they started using the peptides for them. They used it for government officials. Here they're using them for some of the Russian Olympic teams for recovery after competing and so forth. Unfortunately, Chernobyl created a huge cancer radiation issue, but they used these peptides. They brought a lot of these patients to the St. Petersburg facilities, and they used these peptides to basically intervene, and were able to significantly reduce the cancer deaths as a result of the radiation from Chernobyl. Now I'm going to throw at you a lot of clinical studies. We're not going to go through them because you can all read and so forth. I just want you to see that there is proof to all of this, published clinical studies to all of this. Here we're talking about peptide bioregulators. They have become so, what would I call it, so effective that President Putin a couple of years ago gave Professor Khavinson Russia's highest civilian award for his 40 some odd years of medical and scientific service to the Russian people. And this is a photo of him presenting that award. And what Khavinson is saying here is that he believes that peptide pharmaceuticals, in other words, just short peptides rather than large protein peptides and chemical drugs, will become the most crucial development in the world for treating various diseases. These are the peptides that we use in the clinical studies that I administer. There's approximately 23 of them, depending on how you count them. But the point is, there are peptides for the brain, the pineal gland, the adrenal gland, the kidney, the prostate, the vision, the liver, etc. All the major organs have a specific peptide. They are sourced from 12-month-old calves that are very carefully raised. And so what they do is they harvest the organs from a 12-month-old calf, and they take the liver and they do a process of filtering and production and so forth to be able to create these capsules that are 100% food supplements, they call them in Russia, but they're 100% made up of amino acids that come from an animal. And we do this here in America in a very small way. For those people who are on some kind of a thyroid medication, if it's the natural thyroid, oftentimes called Armour or Nature Thyroid, it comes from a pig. If they're on the synthetic versions, they're called Synthroid and so forth. It works on the same principle. So when you take a peptide, let's say for the liver, and you inject it or you swallow it, that liver peptide does not just sit in the digestive system. It passes right through, passes through the membranes, and it goes to the liver of the human being. It doesn't go to the brain. It doesn't go to the heart, just like the thyroid medication that you get from your pharmacy. When you take that, it doesn't go to the brain. It doesn't go to the kidney. It goes to the thyroid. And we won't get into the technology of this. I think, Michelle, we're going to have a question answer period in probably another session. But this just simply shows, this is a pancreas peptide. And what it shows is it's cleaving to the DNA. It goes to what we call the major groove. So it kind of locks on and it will flow through the body. If it's a pancreas peptide, it will flow through the body, pass all the membranes, and it will then attach itself to the pancreas. Not to the liver, not to the brain. It seeks out the organ-specific peptide from which it originally came. So this is what we call biological hallmarks of aging. These are probably the primary, generally most accepted ones. There are others. And so when I was setting up the clinical studies that I was interested in terms of longevity and determining can these peptides be used for longevity, I had to choose, and I chose two different approaches to biological aging. I chose telomeres, and I chose DNA methylation. Those two were chosen because they're probably the most advanced in terms of studies. There are over 4,000 telomere studies on PubMed at this point. But what is very important is that with blood samples, we can actually determine a baseline for telomeres, a baseline for DNA methylation levels, and then the intervention with the peptides, and then a year or so later, we can retest. And so telomere shortening and DNA damage were the most practical biomarkers for aging. So organ regeneration, okay? What the peptides do is at the cellular level, they then start this organ regeneration. And Professor Khavinson calls it biological reprogramming technology. And that's really what it's doing with basically altering, I shouldn't say, turning on and off certain genes, tissue regeneration, etc. So let's take a look, okay? We're going to look at retinal functions. This becomes the evidence, or in science world data, reflecting or basically confirming that these peptides are a powerful organ regeneration. These are the published studies that were put out about 20 some odd years ago. Let me get this out of the way. Okay. These are published studies in Russian with regard to the use of these peptides for retinal interventions, retinal diseases. So What these are we call them field of vision scans. What they show is a before and after on patients, before peptide intervention, after peptide intervention. So this happens to be a diabetic retinoplasty. What you see on my left here is where you see the green, that's what people have left in vision. Where you see the black, they have no vision whatsoever there. Where you see the red, they have a slight bit. When you see the yellow, some vision, but not very good. So the peptide bioregulators for the vision were used for a couple of years, and the field of vision test on the right shows the results where you see a huge amount of green. That means that this person has had restored vision at this point. And it's true for various retinal diseases. Here's macular degeneration. In America, there's very, very little that can be done to restore vision or to even stop the progress of macular degeneration diseases. In Russia, if they catch it early enough, they can almost always stop the progression, but if they catch it early enough, they can then reverse it. So what we have here is on the left, we have a person, macular degeneration, you start losing the vision in the center at this point. And so you see people looking out of the periphery of their eyes all the time with their heads turned. So as we see here, there's black and there's yellow in here, there's some red. So this person probably isn't driving a car anymore because it would be difficult. A couple of years of peptide intervention over here on the right, we see a lot more green and a lot less of the black and the yellow. Here's one of my favorites. This is retinitis pigmentosa. A lot of black in this one before peptide usage. This person basically has no vision to speak of, okay? And a person who has retinitis pigmentosa explains to me that it feels like they're looking through a straw, and all they can see is what they can see through the straw, and then finally the straw closes down where they have nothing. On the right is a person a couple of years after peptides were used, where very little, or I should say there's been a significant increase in the green, a significant decrease in the black. What extent this person's life has changed, I don't know, but I have to make the assumption that with this on the right, that this person has somewhat of an ordinary life versus on the left, they were basically blind. Morbidity. The Russians did some large studies, 11,000 employees of Gazprom, which is a large oil and gas operation in Russia and so forth. What they wanted to know is if they used these peptides, could they reduce the number of sick days that the employees had? So they had 11,000 employees. In the control group, they had 3,000 employees. And at the end of 12 months, they had 2.7 times less acute respiratory disease, lung problems, and total morbidity. In other words, total sickness time off was reduced by 2.3 times. That's a huge windfall to not only the benefit of the individuals who are less sick, but also to the company. So let's go to mortality reduction. This is the study that caught my attention originally, and that is the peptides of the pineal gland and the thymus prolong human life. I saw that and I read through the studies and so forth. Next thing I knew, I was on a plane to St. Petersburg, more or less. And I went knocking on their door some 10 years or so ago. And I said, you have to let me in. I need to know what you're doing. I want to be part of it. They were very gracious about it. They had never seen a scientist or really anyone from America interested in what they were doing. They took me in and I've been with them ever since. See if I can get this box over here out of the way. There we go. Okay. This is one of the published studies. It was shown that long-term treatment with peptide preparations increased the lifespan by 20 to 40%. And we're going to now see this in a summary. So this is a summary of that clinical study that was published. What we have here is two groups of people. We have what the Russians called an elderly group at 60 to 74 years of age. And they have what we call the control group here in the middle in the yellow. And the control group was using what they call polyvitamins. In other words, they weren't using any peptides. They were just doing what they normally would do in terms of their own vitamins and so forth. Let's go down here to the where it says mortality rate in the course of 12 years. After 12 years, in the control group, in this age bracket of 60 to 74, 44% of these people had died. That was the mortality rate. In the peptide group, and this is using just one peptide, as I mentioned earlier, there's about 21 or 22 peptides now, but using just one, because they only had two that they had created at this time. This study is about 25 years old. Using one peptide, they were able to reduce over 12 years in this group of 60 to 74, they were able to drop the mortality rate in half. It was 22%. So it went from 44% to 22% with one peptide. Then we had an older group here, and this is now the group I'm in. I mentioned earlier that the men in my family line die in their 60s and their 50s and 60s, and that's what prompted me to move out of the entrepreneurial world into the medical world. I'm going to be 77 in another 2 months at this point. So this is a group I would be in. The Russians aren't very diplomatic. They call them old people. But in this case, they added a second peptide. And so using two peptides, that's the pineal gland peptide and the thymus peptide, the control group, the people who are not using the peptides, basically it was 81.8% or 82% of these people died, which would be normal over the course of 6 years for that age group. And these are people in Russia and the Ukraine in the study who do not have the same longevity that we have in the West, okay? But using just the pineal gland peptide, they reduced the mortality, because part of this group was only on the one peptide, and another part was on both. But they basically reduced the mortality from 81.8 or 82% down to 33. Huge reduction in mortality. I am unaware of anything in the world, any intervention, any drug, any lifestyle factor that has evidence behind it that shows a reduction from 82% down to 33% in the course of 6 years. The other thing that's very interesting about this study of the older people, actually of both of these studies, they only use the peptides for the first 2 to 3 years. So this study over here, the 12-year study where they reduced by 50% the mortality, they only used the peptides for the first, I think it was 3 years in the 12-year study. And then people were off the peptide. It wasn't continuous like drugs in America. And they only used the peptides for basically about 10 days out of each month for 3 years. And they produced these kind of dramatic mortality reductions. They also have cancer reduction with the peptides. And because we don't have a lot of time, I'm just going to quickly go through. What they were doing was using various chemicals and light and so forth in mice to try and induce tumors. And they found that if they gave these mice peptides beforehand or during treatment, that they could dramatically reduce the tumor incidence. So just taking one, this is the pineal gland peptide. It's a drug-induced tumor. In the control group, they were able to produce a tumor in 81% of those mice. When they had the mice that had a peptide, the one peptide, it reduced down the incidence of tumor to 26%. Dramatic reduction. Okay, so the first study that, well, actually it was the second study, but it's more relevant to present it this way. It's called an epigenetic methylation study. And what epigenetics is, it's basically how do our genes react? What genes can we turn on and turn off? And epigenetics is not about the genes themselves, but it's about what affects our gene, what we call gene expression. In other words, what do we do that supports or doesn't support gene functioning? And so we know that things like diet, stress, exercise, sleep, climate, nutraceuticals, peptides, and so forth can have a positive or sometimes a negative impact on turning on and off genes. And it's all about what we call gene expression. And what the Russians found, and this is a published study, is that if they use these short peptides, they were saying here 2 to 7 amino acids, all the ones that we're using are 2 to 4 amino acids, that they can penetrate into the nucleus of the cells and do things like tissue regeneration, etc. The Russians were studying this. This whole field of DNA methylation is a relatively new one here in the United States. I would say it's gained popularity in the last 5 to 7 years because we can now test for it. The Russians were doing this 20 years ago. This is a book that Khavinson published in 2017, Peptides in the Epigenetic Control of Aging. And what has made it popular is that Dr. Horvath, Stephen Horvath at UCLA, he and his team of scientists have been able to figure out and basically measure and provide a rough epigenetic age or biological age based on based on methylation. So the idea here behind this slide is that we can now measure major organs in the body and come up with a composite DNA methylation, or what we call an epigenetic age. And Horvath says you can think about this whole thing as being rust, that is. So what he found was that if you're aging 8 years faster than your calendar age, that you have a 100% increased risk of dying compared to your same age peers. On the other hand, if you're aging or your epigenetic age is 7 years less than your chronological age, you have half the risk of death. So showing this on a chart, if a person here has, let's say, 7 years older than their chronological age, their epigenetic age, they have an 82.5% increased risk of dying compared to their peers. On the other hand, this shows decreased mortality risk. So if a person was 4 years younger than their chronological age, they have a 28% reduced risk. And so, of course, you don't want to be the increased risk, you want to be in the decreased risk. Horvath says it's great that we can do this, but we don't have a pill or an intervention. And he is unaware that we do. So we did a proof of concept study about 5 or 6 years ago, where we had people who had been on the telomere study, because that was the original study that we started with about 7 years ago. We had people on that study, and when we did a baseline epigenetic, because the commercial epigenetic testing has only really become available last couple of years. Anyway, with the people who had been on a telomeres, 9 subjects, we tested them. They were 5.42 years younger than their chronological age. Then we took a control group of non-peptide people, 15 of those people who had never been on peptides, tested them, and they on average came out about 2 years older. That's what I find now with almost 100 people in the clinical studies, is that Americans tend to be 2 to 4 years older than their epigenetic age. So we put these people on a program, these 15 people that we just talked about that were basically 2 years older at baseline, put them on a 2-year program, and 2 years later, using the peptides, the average group of this 15 were 4.5 years younger than their epigenetic age at this point. Their epigenetic age was. So let's see how it works. So we do these tests. So we see here's Daniel. Daniel had a chronological age of 53. He has a DNA age of 55. So he's 2 years older epigenetically than his chronological age. That's about where a lot of Americans come in. At 2 years older, he has a 25% increased risk of mortality. 2 years later or so, after being on a peptide program, he now was 4 years younger. So his epigenetic age had been reduced from what it was before to 51. He's now 4 years younger than his chronological age. 4 years younger, he has gone now from an increased risk down to a 28% reduced risk. In other words, a significant reduction in all-cause mortality risk. This is a fellow here who baseline at age 57, his epigenetic age was 72, 15 years older. This is a person who's got serious risk factors, a mortality risk of about 200%. We put him on the program, and about 3 years or so later, we had reduced to where he now was only 6 years older, not 15. He still has an increased risk, but dramatically reduced. This is myself. At my baseline, I was 4 years less than my C age because I had been on peptides for a number of years. I retested last year, I think it was, and I had now improved that to I'm 10 years less than my C age. My epigenetic age is 10 years less. We now have the ability to actually determine the epigenetic age of a person's immune system, and that's what this test shows. So this happens to be my test. My immune age is 62 with a biological age last year of 76. And what's interesting is that in the next few months, we're going to be able to, instead of just having an overall epigenetic age assessment, we're going to be able to actually test for and report the epigenetic age of a person's liver, heart, brain, thyroid, stomach, kidneys, etc. In other words, we're going to be able to be organ specific, which will really help us when we are using the peptides to focus on those organs that have an older epigenetic age. This also is fascinating. We can now determine a person's pace of aging, in other words, your rate of aging. So if 1.0 is your chronological age every year, every 12 months, we can also determine what your biological pace of aging is. In this case, this is mine, and mine was at 0.85. That means I'm aging 15% slower than my chronological age. This is a person whose pace of aging is 1.17. He has accelerated aging. I won't go into the details. So this is the type of a protocol that we use. We use all 21 of the various peptides for heart, kidney, muscles, pineal, vision, and so forth. And we do a spreadsheet where we're using various, usually 5 or 6 different peptides every month over the course of a year, and then we retest people. The average decrease in epigenetic age was 4.6 years with 47 participants over a 2-year period. Now, that doesn't seem like a lot, but remember, it's percentage risk reduction that we're looking at. So if a person was 4.6 years older epigenetically than their calendar age, they had about a 60% increase all-cause mortality. Biological age reversal. It is possible to reverse people's biological age. These are what we call telomeres. I don't have time today to go into, but they're the end caps on our chromosomes. And every time we have a cell replication, the end cap shortens a little bit. And there are all sorts of studies that show that if you have that telomeres are linked to aging, to mortality, and to chronic disease. In other words, people with shorter telomeres, and we can measure these telomeres, have a lot of health problems, and they typically don't have the longevity that a person with longer telomeres has. This is Elizabeth Blackburn. She received the Nobel Prize in 2009 for her work with telomeres. And she says longer telomeres have less risk of developing the common illnesses of aging. We know from over 2,000 studies on PubMed that the short telomeres play a central role in every major disease. And this chart shows the various diseases that are associated with short telomeres. This fellow, Michael Fossel, has written the only medical textbook in America that deals with telomeres. He's a brilliant fellow. He's working in this area. His statement is that telomerase activation is the single most promising approach to reversing the effects of aging. He's a wonderful guy. I disagree with him. It is a very important approach. I'm not sure that I would call it the most promising, but it's very important. Same thing with this fellow. Bill Anders is a researcher in this field. He calls it the telomere is the clock of aging, so forth. Yes, it's very important, and it's one of the 2 studies that we're doing, but DNA methylation is equally important, maybe even more important in terms of biological aging. So we ran a clinical study to see if we could lengthen people's telomeres using these peptides. And we had 52 people in the original study. And the peptides did all sorts of wonderful things. They lengthened telomeres. And there we go. Okay. Let me back up here. Okay. These are my labs starting in 2012, before I had anything to do with peptides. At this point, I was 66 years of age. My telomere age, though, on this baseline test was that of a 72-year-old. In other words, I had accelerated aging due to telomere loss. Okay, and it makes sense because we know that stress is a huge driver of shortened telomeres. So I retested a couple of years later. I'm now 68, still not on the peptides. And at this point, my telomeres have shortened even further. I'm at this point, at age 68, I have the telomeres of a 75-year-old. Not a good direction at this point. So October 2015, I meet with the Russians. I go on a telomere program. I go on a peptide program, and I'm now 70, but my telomere age has dropped down to 68, the first time there's been a reversal. And I continue on. This is 2018. I'm 72 years of age at that point, but my telomere age is now 44. A couple more years, I'm 73 at that point. My telomeres are that of a 35-year-old. And I continued, and my telomeres tend to run around 40 right now. This is my significant other, Bess, who at age 60 had accelerated telomere loss. Her telomeres were that of a 63-year-old. We put her on the program, a couple of studies protocols in between. At age 62, her telomeres were brought down to that of a 33-year-old. This is Vess. This I have to disclose, this is not a current picture. She's now going to be 67 this month. This was taken when she was 65, but this is what a 65-year-old healthy with the telomeres of a 33-year-old looks like. She's a competitive ballroom dancer. This is Professor Khavinson sitting there very happily with Vess after we brought in these results where her telomeres were that of a very young adult. This is Tora Bright. Tora Bright is a U.S. Olympic athlete, gold and silver medal winner. Her doctors, Olympic doctors, had done telomere tests, which greatly surprised me, but they did. And her telomere baseline at age 32 was equivalent to a 56-year-old older woman. And I mentioned earlier that stress is what drives that. And of course, these athletes, she had started training at age 3, as I recall. Had been under years and years of stress. So we put her on the protocol. And a couple of years later, we brought her telomeres down to age equivalent, 31. This is the spreadsheet of the people's results. The average reduction in biological age based on telomeres is almost 22 years over the 3-year period. This is the bridge, okay? And what this is, the concept is there are amazing kinds of things coming that are on the cusp of being available that are coming over the next 10 years. And if you look down here at the bottom where it says, it lists some of the major, it says stem cells, DNA repair, telomerase. Okay, well, we're doing the DNA repair and we're doing the telomerase. The idea is if you can stay healthy over the next 10 years, you will be able to take advantage of these kinds of longevity interventions, stem cells, replacement of organs, 3D printing, microbots, and so forth. But you have to stay healthy for this next 10 years. There is more than $10 billion has been invested in research on longevity by these companies. Most of these are billionaires companies, again, as I said, who have a lot less time than they have money. Unfortunately, and they have built campuses and large buildings, and they've hired research staff. Some of these places have 100 scientists working for them. And eventually, I think they're going to turn out something. Right now, they're just turning out research papers. Unfortunately, there is not a single intervention that these labs have produced that actually can be used today safely to make a positive impact on longevity. But the idea is use the peptides to reverse biological age, to regenerate organs, stay healthy for the next 10 years with both the peptides and the other things that people are doing, supplements and exercise and all the rest of that stuff, so we can take advantage of what hopefully these people will discover. So current aging expectations that the world has, and the peptide paradigm of aging that Khavinson and I have at the St. Petersburg Institute is this. And I can safely say that with our peptide program, based on all the evidence, we can extend people's lives 10 to 20 years. I'm 77. I fully expect to be about as healthy as I am today when I hit 100. And that is the program, Michelle.
Wow. I don't know what to say, Bill. I'm just so in awe of everything that you've accomplished, and I'm sure my viewers are feeling the same way. Where do we go from here? I would love to have you come back, and I would love to have a chance to have an interview on many questions that came up as you were presenting. And of course, I didn't want to interrupt. So if that would be okay with you, we'll schedule something maybe in the mid part of July or whenever it's good for you. But before we say goodbye, because I think we have almost run out of time, why don't you just give us a quick summary of where you see yourself going in the next 5 years?
I'm going to be going across that bridge that I showed you, because those things, the peptides are not the sole answer. That is, they are the most amazing thing available today. Okay, there is nothing else that comes close to doing what these peptides can do. Other peptides that you see advertised and so forth have some value. The ones that, like BPC 157 is great for wound healing and so forth. There's energy peptides, there's weight loss peptides, and those are great things to do because that's quality of life.
Right.
And I had a doctor I was talking to the other day said to me, Bill, what you don't realize is that, he was like almost 80. He says, what that does for me is it tells me I've got at least 10 or 15 years of life. Whereas on the other hand, I was thinking about, I need to go update my will at this point. And that's the psychological impact. So to answer your question, I will continue doing the research with the clinical studies on these peptides, but I'm also looking at everything else that might be available.
Well, for people that want to take the initiative to be part of this, I know that you're accepting only medical people into your clinical studies. I just want to be very clear about this to anyone that's watching today, that if you are a medical person and you have an interest, please do not contact Dr. Bill Laurence. Please contact me because I'm going to be the initial screener for anyone that would be presented to him. Bill, thank you so much for today, and I want to wish everyone a wonderful weekend. And before we say goodbye, just to let you know that my phone number, if you want to reach me, is it's 808-639-0904. And feel free to call me to let me know if you have interest, if you are a medical practitioner. Okay, thank you so much, Bill. Have a beautiful weekend, and we'll be talking to set up our next meeting.
Thank you, Michelle. It's been a pleasure.
Okay. All right, take care. Bye-bye. Bye.